Hey kiddos, it is Miss Lloyd today, bringing you some multiple angles and some product to sum formulas. Yes, I am. You may want to pause because I'm not going to go through every single one of these, and there's a lot. So here's our double angle formulas, our power reducing formulas for when you don't want that squared. We've got our half angle formulas. We've got our product to sum formulas. And then lastly, we've got our sum to product formulas. You're welcome. For our first example, we are going to solve cosine of 2x plus cosine x that is equal to 0. So the first thing that I notice when I'm looking at this is the cosine of 2x. That's a double angle. So I go back up to my double angle formulas. I don't remember where it is. There it is. It was one of the first ones. And I've got some options. And here I don't want to use sine because I already have cosine. So I would rather use something that just has cosine, which means I'm going to be using this second formula. It's nice when you have choices. Sometimes too many choices can give you a migraine. In this case, though, I already have cosine. I would like to just work with the same trig function. So I'm going to use the 2 times cosine squared minus 1. So instead of my cosine 2x, I am replacing it with what it is equivalent to using the double angle formula. And we're using x instead of u. That's okay. I'm going to move some things around because I don't like the order of this. It just does not vibe with me. And I know what you're thinking. This looks like a quadratic. We've got a squared, we've got a linear term, we've got a constant, and you are right. I'm going to be using M and A. If M and A freaks you out because of the cosines, we can always do U substitution. So when I'm doing M and A, now that I don't have the cosines kind of get in the way and freaking me out, I can use M multiplying to get that 2 and minus 1 for a negative 2, and we're adding to get our middle term, which is 1. I am going to have to split the middle here because I have a leading coefficient that is not 1. I know that's a bummer, but it's something we can do. I believe in us. I really do. Whew, that was very fast. Anyway, so I've got my u's, but that's not all. It didn't ask me to solve for u, it asked me to solve for x. So I have to remember now that I have my u's, I've got to undo that u substitution that I did before, and I'm going to do that off to the side because I've run out of room on this page. So I said before that u was equal to cosine of x, so where I have a u, like u is equal to 1/2, I'm going to cosine of x is equal to 1/2. And where I have another thing, like u is equal to -1, I'm going to have cosine is equal to -1. So from here, I'm trying to figure out at what angle is cosine going to be positive half. And so for this, I like to use my trig hand trick. I know cosine is to the left of my bent finger, and so I'm looking to where there's only 1, and that's going to be pi over 3. Or 60 degrees if you want to be all degrees with it instead of radians. I kind of am really liking radians right now because of the pi. I was born on Pi Day, and it's just all around a beautiful number, let's be honest. But not only is cosine positive in the first quadrant, whereas pi over 3 is also positive in the fourth quadrant because it's an x value, and x is positive in the first and the fourth quadrants. What? And so that means that I'm also looking at 5 pi over 3, which is the similar angle to pi over 3. It has a cosine of positive 1/2 in the fourth quadrant. Yes. The last one that I'm going to be looking at is that cosine of -1. There's only one place on the unit circle where our x value is going to be -1, or our cosine is going to be -1, and that is at pi. So it's on the x-axis when we just go to the left one from the origin. Pi, again, it's beautiful. It really is. Just look at it. Just look at it. It's beautiful. All right, and those are our solutions. I've also probably been watching way too much TikTok, let's be honest. Next one, we're going to use the conditions below. Use. I definitely had a typo. Sue me. So we are going to use the conditions below to figure out sine of these double angles. We got sine double angle, cosine double angle, tangent double angle. I'm only going to be doing sine double angle, so sine 2 theta for this situation. And the other two, I'm going to have my kiddos do after I do the hard part, which is creating the triangle, because if we have sine of 3/5, and they told us opposite over hypotenuse because of SOHCAHTOA. So yeah, and I also know that this is going to be in the first quadrant because they're telling me that theta, the angle, is in between 0 and pi/2. So 0 and 90 degrees, that's the first quadrant. I really have been watching too much TikTok. So I'm going to create this triangle in the first quadrant that has the opposite of 3, the hypotenuse being 5. And that means I need to figure out what the adjacent is, because if I have some stuff where I'm going to be using cosine, I'm probably going to want to know the cosine of this angle. And so with that, I can use the Pythagorean theorem. Pythagorean theorem. What's wrong with my face? So now I have my x, I have the opposite, the adjacent, and the hypotenuse of my triangle. So then I know the tangent and the cosine of this triangle of the angle theta. I win. So now that I have that, I'm going to go through and do these double angle identities. So my sine of 2 theta, if I were to do the double angle for that, our formula is going to look like 2 times sine of theta times cosine of theta. And they told me what sine theta is. And my beautiful, beautiful brain has found the cosine of theta. And now I just got to simplify this stuff, multiplying my fractions across the top and bottom, and then multiplying the top by 2. I can't do any more reducing, so this is as far as I can go. And again, I'm going to save the cosine and tangent double angles for my kiddos, as well as that problem and that problem. And oh, look, here's one that I'm going to do on here. This next one, we want to find the exact value of cosine of 105 degrees. I don't like 105 degrees. One, that sounds disgusting, and two, it's not one of the pretty ones on the unit circle. So that means that I want this to be one of the pretty ones on the unit circle. Why can't it be one of the pretty ones on the unit circle? I'm going to make it one of the pretty ones on the unit circle. So something I know about 105, it's not one of the pretty ones on the unit circle, but if I multiplied this by 2, I would get 210, and 210 is something that's pretty on the unit circle. Which means I could change this up a little bit and say that it's 210 divided by 2, and then I have a half angle identity. I also probably want to keep in mind that whenever I'm doing this, 210 degrees is in the third quadrant. It's in between 180 and 270. And I want to keep this in mind because cosine is negative in the third quadrant. So when I'm doing my half angle identity, I'm going to be using the formula that I already had at the beginning of the video, which is square root 1 plus cosine of 210 degrees divided by 2. And when I did these identities, I did have a plus minus in the front. And that plus minus in the front, same thing goes for the sine. It is one or the other, it's not both. It depends on which quadrant you are in. So depending on which quadrant I'm in is going to determine what I'm using for the plus or the minus. So we can see here that this angle, 105 degrees, is in between 90 and 180, which means that this angle is in quadrant 2. Because this angle is in quadrant 2 and we're looking at the cosine of this angle, I'm going to make this entire square root negative because cosine is negative in the second quadrant. So from here I can start plugging in what I know and simplifying. So when it comes to cosine of 210 degrees, we've said it's in quadrant 3. We know cosine will end up being negative. I also know that the reference angle is going to be 30 degrees. So because I have the reference angle of 30 degrees, I'm looking at cosine of 30 degrees and I'm making it negative because we're in quadrant 3. And that means we're going to have negative square root 3 over 2. And now I just have to do a bunch of simplifying inside that radical. And hopefully we won't end up with any radicals in the denominator, otherwise we gotta rationalize. And so I've done all my simplifying. It's still kind of gross because we have some radicals inside of radicals, but there's really not much more we can do from here. We don't have any radicals in the denominator. It's all rationalized. This is also the last problem that I'm doing with y'all. So if you found this helpful, please like and subscribe. And if you think this could be helpful for someone else, spread that love.